Thank you for attending our presentation. I will introduce our paper, Model-Agnostic Gender-Debiased Image Captioning. Image captioning models are known to perpetuate and amplify harmful societal bias. While prior work has addressed this problem by reducing gender misclassification, it conversely generates gender stereotypical words at the expense of predicting the correct gender. From this observation, we hypothesize that there are two types of gender biases affecting captioning models. First, context to gender bias that exploits context to predict gender. Second, gender to context bias in the probability of generating certain words because of gender. To mitigate both types of biases, we propose a framework that learns from synthetically biased samples, correcting gender misclassification and changing gender stereotypical words to more neutral ones. In this work, we work on societal bias in image captioning. Previous work has shown that image captioning models perpetuate and amplify societal bias such as gender bias and ethnicity bias. Based on the observations in the previous work, we hypothesize there are two different types of biases affecting captioning models. First, context to gender bias, which makes models exploit the context of an image and precedently generated words, increasing the probability of predicting certain gender. Second, gender to context bias, which increases the probability of generating certain words given the gender of people. Prior work focuses on mitigating context to gender bias by forcing the models to see image fusion with a person. However, it conversely amplifies gender to context bias, generating gender stereotypical words. Red dress in this example. In this work, we propose a framework called LIBRA that mitigates bias amplification in image captioning by considering both types of biases. The idea behind the proposed framework, LIBRA, is as follows. A model trained to correct both context to gender and gender to context biases in captions will be able to amend these biases in any captioning model's output. Our proposed LIBRA is model-agnostic, which can be applied to on top of any captioning models, and also it mitigates both types of biases. Specifically, LIBRA consists of two main modules: biased caption synthesis, which synthesizes captions with context to gender and gender to context biases, and debiasing caption generator that mitigates gender bias in the input caption. First, I introduce biased caption synthesis. To synthesize caption with context to gender bias, we first mask the gender-related words, such as women, in the caption to remove gender information. The caption with the gender-related words masked represents the context of the image other than gender. After that, we judge whether the context is biased toward which gender by using a classifier. The classifier takes a caption with gender words masked and predicts whether the context of the image is biased toward women or men. Then, if the prediction doesn't match with the original gender, we swap the gender words in the caption to make it consistent with the context. The swapped incorrect gender can be considered due to context to gender bias. On the other hand, to synthesize caption with gender to context bias, we first randomly mask 15% of the words in the caption. After that, the masked word generator by T5 can complete the masked words, resulting in generating various different captions. Then, we filter out the generated captions that decrease gender to context bias by using the same classifier that classify if the input caption's context is skewed toward women or men. As a result, The synthesized captions contain gender-stereotypical words that often co-occur with the gender, amplifying gender-to-context bias. Devising caption generator is trained to recover the original caption given a synthetic biased caption and image pair. Once trained, it can be used on top of any captioning models to mitigate gender bias by taking a generated caption and image pair as input. We evaluate gender-to-context bias of various captioning models before and after applying LIBRA. The result shows that LIBRA mitigates gender-to-context bias in all the models. We also evaluate context-to-gender bias before and after applying LIBRA. The results show that LIBRA mitigates context-to-gender bias in most models. We show some examples that LIBRA mitigates gender bias. As for gender-to-context bias, LIBRA tends to change words skewed toward each gender to less biased ones. For instance, in the left example, the baseline produces the incorrect words, suits, which is skewed toward men in Coco. LIBRA changes suits to jacket, mitigating gender-to-context bias. As for context-to-gender bias mitigation, LIBRA corrects gender misclassification caused by the context. For example, in the right sample, the baseline predicts incorrect gender, man, probably due to the male-skewed context, surfboarding. LIBRA predicts correct gender, mitigating context-to-gender bias. We compare LIBRA with the other bias mitigation method, equalizer. Equalizer is a bias mitigation method to force the model to see people in the image to predict the correct gender and successfully reduce gender misclassification. Whereas equalizer generates the woman-skewed word, bikini, at the expense of predicting the correct gender, LIBRA predicts the correct gender while not generating gender-stereotypical words.